Hello. In this video, we're going to look at some of the properties of the real numbers and then use these properties to reduce large expressions. So I've already written out a few of the bigger properties. Closure really is just saying when we're doing something with numbers, they're going to stay in the real numbers. So if I'm adding two real numbers, it's still real. Multiplying, dividing, all of that, it's still real numbers. The only issue we could run into is when b is 0 and I'm dividing by 0. This is just not a real number. So that one's pretty easy. Commutativity, it's saying that the order doesn't matter with addition or multiplication, but it really does matter with subtraction and division. This is really easy to check. If I plug in just really any numbers, I can see that this order really does matter. And that'll run us into trouble, and that's why we have some tools that we'll use when determining how we reduce these large expressions. But that's just something to keep in mind. The order matters with subtraction and division. And the same kind of thing over here. With associativity, it doesn't matter how I group these things in order to add or multiply, but because the order matters with subtraction and division, it does matter when I'm trying to group. So let's say I just plug in some numbers real quick. If I'm trying to subtract 3, 4, and 5, 3, just increase that, 4, 5, we can see here that this ordering really does change the outcome. I get -6 is not equal to 4. That's very far apart. So again, because of commutativity, because the order matters with subtraction and division, it matters how I'm grouping things together, which is really all associativity is saying. And then finally, with distribution, I can think of b plus c as two separate terms. And when I distribute, I would multiply that a to both of them. Same thing with subtraction. But when I'm looking at multiplication and division, this multiplication of b times c, really I should think about this as one thing. So if I'm going to distribute, really, I'm just multiplying it once. I don't want to over multiply. Same thing with division. If I'm thinking about b divided by c, I'm thinking about it as this one fraction. So I'll only multiply it once on the top. Okay, so again, commutativity says that the order matters for subtraction and division, and so that gets us the order matters when grouping. And then with distribution, we want to think of multiplication and division as one thing inside the parentheses. So I can see that this little PEMDAS is showing up here. This is going to tell us our ordering when we're doing things. So let me erase all of this. So it's possible you haven't seen it written like this. But when we're talking about PEMDAS or the order that we're going to do things in, it really is parentheses. Oh, I don't know how to spell. So we're going to do everything that we can inside the parentheses first. We'll do all of it that we can, and then we're going to move on to exponents. And really, these never give us any trouble. Because once we're in the parentheses, we're going to stay in there. Once we're doing these exponents, the exponents are normally either just something, either 2 to the third, or it's something within parentheses, so we know to keep that separate. So these rarely give us any trouble. But it's where multiplication and division come in. These are done from left to right. So I'll do any multiplication or division that I see, and I'll decide between whether I'm doing multiplication or division by going left to right. This is a hangover from when we used to do mathematics. We just need a way to be unambiguous because, again, the order matters with division in this case. So we just want to be unambiguous. We want one single answer when we're doing this. And it'll be the same thing for addition and subtraction, left to right. So let's look at how these actually work with some examples. So for this first one, this is pretty straightforward. We're going to distribute this 5. And again, I'm treating this 4W as one thing. So I have 20W minus 30. And then I'm going to distribute again. 9W plus 6. So now I'll read left to right. So I have 20W minus 30. Well, I can't combine this. So now I have 20W minus 30 plus 9W. So the 20W plus 9W I can do something with. I'll get 29W. So now I have 29W minus 30 plus 6, and I can combine these to get negative 24. So in this case, the PEMDAS, this order that we were doing things in, really didn't come up. We only had this one negative, and since all of the terms were different, I didn't really have to worry about the ordering. Well, let's move to the next one. This one looks a little bit tougher. So what I'll do first, I'll look at my parentheses. I can't combine these two terms. I have a z and a y. I don't know what these are. I don't have any exponents. So now I'll start multiplying and dividing from left to right. So negative 3y times 2 is negative 6y. I have this parentheses, negative z plus 2y. And then now I need to divide by 2z. So I'll divide this parentheses by 2z. So really it's dividing this entire thing. So this is where that ordering actually came in and mattered. It would look very different if I waited until the very end to divide. All right, so now I can distribute. (42yz) minus 12y squared all over 2z. And then I'd want to just reduce. This 2 can go into each of these pieces. So it'd be 21yz minus 6y squared z. So this one was a little bit complicated. I don't believe you're going to see anything this complicated on your homeworks, because really this is more of a tedious question that I just put in here to show that the order does matter with PEMDAS. Now this last one, is something more like you would see on the Mastery Moment when we're testing on this module. We have multiple parentheses, because in this case this bracket is going to act as a parentheses, and the order may or may not come into play. So I have negative 5, negative 3x minus 3. So as is, I can't combine anything in this parentheses, but I need to work on combining everything inside that I can. And in order to do that, I need to distribute out this negative 6. So that'll give me negative 6x minus 6. So again, I'm going to read left to right, but I only have two terms. I have this negative 3x and negative 6x that I can combine, and then I have the negative 3 and negative 6 that I can combine. So the order doesn't come up in this one. I'll get negative 9x minus 9. And then I'll finally distribute. 45x plus 45. And that'll be it. So if I had a few more terms inside, that ordering might matter. And that's something that you could expect on the mastery moment. But for now, since there were only 2 that I could combine of each, the order didn't matter. All right, and that's everything with this. So when you're thinking about this, you want to think about PEMDAS, and again, the order matters for subtraction and division, and that really does change things for commutativity and associativity.